Hello everyone. Question is, a company has a mobile application that makes HTTP API calls to an application load balancer ALB. The ALB routes request to an AWS Lambda function. Many different versions of the application are in use at any given time, including versions that are in testing by a subset of users. The version of the application is defined in the user agent header that is sent with all requests of the API. After a series of recent changes to the API, the company has observed issues with the application. The company needs to gather a metric for each API operation by response code for each version of the application that is in use. A DevOps engineer has modified the Lambda function to extract the API operation name, version information from the user agent header and response code. Which additional set of actions should the DevOps engineer take to gather the required metrics? Option A. Modify the Lambda function to write the API operation name, response code, and version number as a log line to an Amazon CloudWatch logs log group. Configure a CloudWatch logs metric filter that increments a metric for each API operation name. Specify response code and application version as dimensions for the metric. Option B. Modify the Lambda function to write the API operation name, response code, and version number as a log line to an Amazon CloudWatch logs log group. Configure a CloudWatch logs insights query to populate CloudWatch metrics from the log lines. Specify response code and application version as dimensions for the metric. Option C. Configure the ALB access logs to write to an Amazon CloudWatch logs log group. Modify the Lambda function to respond to the ALB with the API operation name, response code, and version number as response metadata. Configure a CloudWatch logs metric filter that increments a metric for each API operation name. Specify response code and application version as dimensions for the metric. Option D. Configure AWS X-ray integration on the Lambda function. Modify the Lambda function to create an X-ray subsegment with the API operation name, response code, and version number. Configure X-ray insights to extract an aggregated metric for each API operation name and to publish the metric to Amazon CloudWatch. Specify response code and application version as dimensions for the metric. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company provides an application to customers. The application has an Amazon API gateway REST API that invokes an AWS Lambda function. On initialization, the Lambda function loads a large amount of data from an Amazon DynamoDB table. The data load process results in long cold start times of 8 to 10 seconds. The DynamoDB table has DynamoDB Accelerator DAX configured. Customers report that the application intermittently takes a long time to respond to requests. The application receives thousands of requests throughout the day. In the middle of the day, the application experiences 10 times more requests than at any other time of the day. Near the end of the day, the application's request volume decreases to 10% of its normal total. A DevOps engineer needs to reduce the latency of the Lambda function at all times of the day. Which solution will meet these requirements? Option A, configure provision concurrency on the Lambda function with a concurrency value of 1. Delete the DAX cluster for the DynamoDB table. Configure reserved concurrency on the Lambda function with a concurrency value of 0. Option B, configure provisioned concurrency on the Lambda function. Configure AWS application auto-scaling on the Lambda function with provisioned concurrency values set to a minimum of 1 and a maximum of 100. Option C, configure reserved concurrency on the Lambda function. Configure AWS application auto-scaling on the API gateway API with a reserved concurrency maximum value of 100. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company is adopting AWS Code Deploy to automate its application deployments for a Java Apache Tomcat application with an Apache web server. The development team started with a proof of concept, created a deployment group for a developer environment, and performed functional tests within the application. After completion, the team will create additional deployment groups for staging and production. The current log level is configured within the Apache settings, but the team wants to change this configuration dynamically when the deployment occurs, so that they can set different log level configurations depending on the deployment group without having a different application revision for each group. How can these requirements be met with the least management overhead and without requiring different script versions for each deployment group? Option A, tag the Amazon EC2 instances depending on the deployment group. Then place a script into the application revision that calls the metadata service and the EC2 API to identify which deployment group the instance is part of. Use this information to configure the log level settings. Reference the script as part of the after install lifecycle hook in the appspec.yml file. Option B, create a script that uses the code deploy environment variable deployment underscore group underscore name to identify which deployment group the instance is part of. Use this information to configure the log level settings. Reference this script as part of the before install lifecycle hook in the appspec.yml file. Option C, create a code deploy custom environment variable for each environment. Then place a script into the application revision that checks this environment variable to identify which deployment group the instance is part of. Use this information to configure the log label settings. Reference this script as part of the validate service lifecycle hook in the appspec.yml file. Option D, create a script that uses the code deploy environment variable deployment underscore group underscore ID to identify which deployment group the instance is part of to configure the log label settings. Reference this script as part of the install lifecycle hook in the appspec.yml file. Correct answer is option D. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company requires its developers to tag all Amazon Elastic Block Store Amazon EBS volumes in an account to indicate a desired backup frequency. This requirement includes EBS volumes that do not require backups. The company uses custom tags named backup_frequency that have values of none, daily, or weekly that correspond to the desired backup frequency. An audit finds that developers are occasionally not tagging the EBS volumes. A DevOps engineer needs to ensure that all EBS volumes always have the backup_frequency tag so that the company can perform backups at least weekly unless a different value is specified. Which solution will meet these requirements? Option A. Set up AWS config in the account. Create a custom rule that returns a compliance failure for all Amazon EC2 resources that do not have a backup frequency tag applied. Configure a remediation action that uses a custom AWS Systems Manager automation runbook to apply the backup_frequency tag with a value of weekly. Option B. Set up AWS config in the account. Use a managed rule that returns a compliance failure of EC2 volume resources that do not have a backup frequency tag applied. Configure a remediation action that uses a custom AWS Systems Manager automation runbook to apply the backup_frequency tag with a value of weekly. Option C. Run on AWS CloudTrail in the account. Create an Amazon Event Bridge rule that reacts to EBS create volume events. Configure a custom AWS Systems Manager automation runbook to apply the backup_frequency tag with a value of weekly. Specify the runbook as the target of the rule. Option D. Turn on AWS CloudTrail in the account. Create an Amazon Event Bridge rule that reacts to EBS create volume events or EBS modify volume events. Configure a custom AWS System Manager automation runbook to apply the backup_frequency tag with a value of weekly. Specify the runbook as the target of the rule. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company must encrypt all AMIs that the company shares across accounts. A DevOps engineer has access to a source account where an unencrypted custom AMI has been built. The DevOps engineer also has access to a target account where an Amazon EC2 auto-scaling group will launch EC2 instances from the AMI. The DevOps engineer must share the AMI with the target account. The company has created an AWS Key Management Service (AWS KMS) key in the source account. Which additional steps should the DevOps engineer perform to meet the requirements? Choose three options. Option A. In the source account, copy the unencrypted AMI to an encrypted AMI. Specify the KMS key in the copy action. Option B. In the source account, copy the unencrypted AMI to an encrypted AMI. Specify the default Amazon Elastic Block Store Amazon EBS encryption key in the copy action. Option C. In the source account, create a KMS ground that delegates permissions to the auto-scaling group service linked role in the target account. Option D. In the source account, modify the key policy to give the target account permissions to create a grant. In the target account, create a KMS grant that delegates permissions to the auto-scaling group service-linked rule. Option E. In the source account, source the unencrypted AMI with the target account. Option F. In the source account, share the encrypted AMI with the target account. Correct answer is option A, D, and option F. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, an e-commerce company has chosen AWS to host its new platform. The company's DevOps team has started building an AWS control tower landing zone. The DevOps team has set the identity stored within AWS IAM Identity Center AWS single sign-on to external identity provider ADP and has configured SAML 2.0. The DevOps team wants a robust permission model that applies the principle of least privilege. The model must allow the team to build and manage only the team's own resources. Which combination of steps will meet these requirements? Choose three options. Option A. Create IAM policies that include the required permissions, include the AWS principal tag condition key. Option B. Create permission sets, attach an inline policy that includes the required permissions and uses the AWS principal tag condition key to scope the permissions. Option C. Create a group in the IDP. Place users in the group. Assign the group to accounts and permission sets in IAM Identity Center. Option D. Create a group in the IDP. Place users in the group. Assign the group to OUs and IAM policies. Option E. Enable attributes for access control in IAM Identity Center. Apply tags to users. Map the tags as key value pairs. Option F. Enable attributes for access control in IAM Identity Center. Map attributes from the IDP as key value pairs. Correct answer is option B, C, and option F. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a development team is using AWS Code Commit to version control application code and AWS Code Pipeline to orchestrate software deployments. The team has decided to use a remote main branch as the trigger for the pipeline to integrate code changes. A developer has pushed code changes to the code commit repository, but noticed that the pipeline had no reaction, even after 10 minutes. Which of the following actions should be taken to troubleshoot this issue? Option A. Check that an Amazon Event Bridge rule has been created for the main branch to trigger the pipeline. Option B. Check that the code pipeline service role has permissions to access the code commit repository. Option C. Check that the developer's IAM role has permission to push to the code commit repository. Option D. Check to see if the pipeline failed to start because of code commit errors in the Amazon CloudWatch logs. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a DevOps engineer is creating an AWS CloudFormation template to deploy a web service. The Wave service will run an Amazon EC2 instances in a private subnet behind an application load balancer ALB. The DevOps engineer must ensure that the service can accept requests from clients that have IPv6 addresses. What should the DevOps engineer do with the CloudFormation templates so that IPv6 clients can access the Wave service? Option A. Add an IPv6 CIDR block to the VPC and the private subnet for the EC2 instances. Create route table entries for the IPv6 network. Use EC2 instance types that support IPv6 and assign IPv6 addresses to each EC2 instance. Option B. Assign each EC2 instance an IPv6 elastic IP address. Create a target group and add the EC2 instances as targets. Create a listener on port 443 of the ALB and associate the target group with the ALB. Option C. Replace the ALB with the network load balancer NLB. Add an IPv6 CIDR block to the VPC and subnets for the NLB, and assign the NLB an IPv6 elastic IP address. Option D. Add an IPv6 CIDR block to the VPC and subnets for the ALB. Create a listener on port 443 and specify the dual stack IP address type on the ALB. Create a target group and add the EC2 instances as targets. Associate the target group with the ALB. Correct answer is option D. Question is, a company has containerized all of its in-house quality control applications. The company is running Jenkins on Amazon EC2 instances, which require patching and upgrading. The compliance officer has requested a DevOps engineer begin encrypting build artifacts since they contain company intellectual property. What should the DevOps engineer do to accomplish this in the most maintainable manner? Option A. Automate patching and upgrading using AWS Systems Manager on EC2 instances and encrypt Amazon EBS volumes by default. Option B. Deploy Jenkins to an Amazon ECS cluster and copy build artifacts to an Amazon S3 bucket with default encryption enabled. Option C. Leverage AWS code pipeline with a build action and encrypt the artifacts using AWS Secrets Manager. Option D. Use AWS code build with artifact encryption to replace the Jenkins instance running on EC2 instances. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company runs an application on one Amazon EC2 instance. Application metadata is stored in Amazon S3 and must be retrieved if the instance is restarted. The instance must restart or relaunch automatically if the instance becomes unresponsive. Which solution will meet these requirements? Option A. Create an Amazon CloudWatch alarm for the status check failed metric. Use the recover action to stop and start the instance. Use an S3 event notification to push the metadata to the instance when the instance is back up and running. Option B. Configure AWS OpsWorks and use the auto-healing feature to stop and start the instance. Use a lifecycle event in OpsWorks to pull the metadata from Amazon S3 and update it on the instance. Option C. Use EC2 auto recovery to automatically stop and start the instance in case of a failure. Use an S3 event notification to push the metadata to the instance when the instance is back up and running. Option D. Use AWS CloudFormation to create an EC2 instance that includes the user data property for the EC2 resource. Add a command in user data to retrieve the application metadata from Amazon S3. Correct answer is option C. Question is, a company has an organization in AWS organizations. The organization includes workload accounts that contain enterprise applications. The company centrally manages users from an operations account. No users can be created in the workload accounts. The company recently added an operations team and must provide the operations team members with administrator access to each workload account. Which combination of actions will provide this access? Choose three options. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Now the options are: option A. Create a sysadmin role in the operations account. Attach the administrator access policy to the role. Modify the trust relationship to allow the STS assume role action from the workload accounts. Option B. Create a sysadmin role in each workload account. Attach the administrator access policy to the role. Modify the trust relationship to allow the STS assume role action from the operations account. Option C. Create an Amazon Cognito identity pool in the operations account. Attach the sysadmin role as an authenticated role. Option D. In the operations account, create an IAM user for each operations team member. Option F. In the operations account, create an IAM user group that is named sysadmins. Add an IAM policy that allows the STS assume role action for the sysadmin role in each workload account. Add all the operations team members to the group. Option F. Create an Amazon Cognito user pool in the operations account. Create an Amazon Cognito user for each operations team members. Correct answer is option A, B, and option E. Question is, a company has migrated its container-based applications to Amazon EKS and want to establish automated email notifications. The notifications sent to each email address are for specific activities related to EKS components. The solution will include Amazon SNS topics and an AWS Lambda function to evaluate incoming log events and push messages to the correct SNS topic. Which logging solution will support these requirements? Option A. Enable Amazon CloudWatch logs to log the EKS components. Create a CloudWatch subscription filter for each component with Lambda as the subscription feed destination. Option B. Enable Amazon CloudWatch logs to log the EKS components. Create CloudWatch logs inside queries linked to Amazon EventBridge events that invoke Lambda. Option C. Enable Amazon S3 logging for the EKS components. Configure an Amazon CloudWatch subscription filter for each component with Lambda as the subscription feed destination. Option D. Enable Amazon S3 logging for the EKS components. Configure S3 put object event notifications with AWS Lambda as the destination. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company is using AWS code pipeline to automate its release pipeline. AWS Code Deploy is being used in the pipeline to deploy an application to Amazon Elastic Container Service Amazon ECS using the blue-green deployment model. The company wants to implement scripts to test the green version of the application before shifting traffic. These scripts will complete in 5 minutes or less. If errors are discovered during these tests, the application must be rolled back. Which strategy will meet these requirements? Option A, add a stage to the code pipeline between the source and deploy stages. Use AWS code build to create a runtime environment and build commands in the build spec file to invoke test scripts. If errors are found, use the AWS deploy stop deployment command to stop the deployment. Option B, add a stage to the code pipeline between the source and deploy stages. Use this stage to invoke an AWS Lambda function that will run the test scripts. If errors are found, use the AWS deploy stop deployment command to stop the deployment. Option C, add a hooks section to the code deploy app spec file. Use the after allow test traffic lifecycle event to invoke an AWS Lambda function to run the test scripts. If errors are found, exit the Lambda function with an error to initiate rollback. Option D, add a hooks section to the code deploy app spec file. Use the after allow traffic lifecycle event to invoke the test scripts. If errors are found, use the AWS deploy stop deployment CLI command to stop the deployment. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a space exploration company receives telemetry data from multiple satellites. Small packets of data are received through Amazon API Gateway and are placed directly into an Amazon Simple Queue service, Amazon SQS standard queue. A custom application is subscribed to the queue and transforms the data into standard format. Because of inconsistencies in data that the satellite produces, the application is occasionally unable to transform the data. In these cases, the messages remain in the SQS queue. A DevOps engineer must develop a solution that retains the failed messages and makes them available to scientists for review and future processing. Which solution will meet these requirements? Option A, configure AWS Lambda to poll the SQS queue and invoke a Lambda function to check whether the queue messages are valid. If validation fails, send a copy of the data that is not valid to an Amazon S3 bucket so that the scientist can review and correct the data. When the data is corrected, amend the message in the SQS queue by using a replay Lambda function with the corrected data. Option B, convert the SQS standard queue to an SQS FIFO queue. Configure AWS Lambda to poll the SQS query every 10 minutes by using an Amazon Event Bridge schedule. Invoke the Lambda function to identify any messages with a sent timestamp value that is older than 5 minutes. Push the data to the same location as the application's output location and remove the messages from the queue. Option C, create an SQS dead letter queue. Modify the existing queue by including a redrive policy that sets the maximum receives setting to 1 and sets the dead letter queue ARN to the ARN of the newly created queue. Instruct the scientist to use the dead letter queue to review the data that is not valid. Reprocess this data at a later time. Option D. Configure API gateway to send messages to different SQS virtual queues that are named for each of the satellites. Update the application to use a new virtual queue for any data that it cannot transform and send the message to the new virtual queue. Instruct the scientist to use the virtual queue to review the data that is not valid. Reprocess this data at a later time. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a DevOps engineer is building a multi-stage pipeline with AWS code pipeline to build, verify, stage, test, and deploy an application. A manual approval stage is required between the test stage and the deploy stage. The development team uses a custom chat tool with webhook support that requires near real-time notifications. How should the DevOps engineer configure status updates for pipeline activity and approval requests to post to the chat tool? Option A. Create an Amazon Cloud Watch Logs subscription that filters on code pipeline execution state change. Publish subscription events to an Amazon Simple Notification Service Amazon SNS topic. Subscribe the chat webhook URL to the SNS topic and complete the subscription validation. Option B. Create an AWS Lambda function that is invoked by AWS CloudTrail events. When a code pipeline execution state change events is detected, send the event details to the chat webhook URL. Option C. Create an Amazon Event Bridge rule that filters on code pipeline execution state change. Publish the events to an Amazon Simple Notification Service Amazon SNS topic. Create an AWS Lambda function that needs event details to the chat webhook URL. Subscribe the function to the SNS topic. Option D. Modify the pipeline code to send the event details to the chat webhook URL at the end of each stage. Parameterize the URL so that each pipeline can send to a different URL based on the pipeline environment. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company wants to use AWS deployment tools to replace its current bash deployment scripts. The company currently deploys a LAMP application to a group of Amazon EC2 instances behind an application load balancer ALB. During the deployments, the company unit tests the committed application, stops and starts services, unregisters and re-registers instances with the load balancer, and updates file permissions. The company wants to maintain the same deployment functionality through the shift to using AWS services. Which solution will meet these requirements? Option A. Use AWS code build to test the application. Use bash scripts invoked by AWS code deploys appspec.yml file to restart services and deregister and register instances with the ALB. Use the appspec.yml file to update file permissions without a custom script. Option B. Use AWS code pipeline to move the application from the AWS code commit repository to AWS code deploy. Use code deploys deployment group to test the application. Unregister and re-register instances with the AL and restart services. Use the appspec.yml file to update file permissions without a custom script. Option C. Use AWS code pipeline to move the application source code from the AWS code commit repository to AWS code deploy. Use code deploy to test the application. Use code deploy's appspec.yml file to restart services and update permissions without a custom script. Use AWS code build to unregister and re-register instances with the ALB. Option D. Use AWS code pipeline to trigger AWS code build to test the application. Use bash scripts invoked by AWS code deploys appspec.yml file to restart services. Unregister and re-register the instances in the AWS code deploy deployment group with the ALB. Update the appspec.yml file to update file permissions without a custom script. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a rapidly growing company wants to scale for developer demand for AWS development environments. Development environments are created manually in AWS Management Console. The networking team uses AWS CloudFormation to manage the networking infrastructure, exporting stack output values for the Amazon VPC and all subnets. The development environments have common standards such as application load balancers, Amazon EC2 auto-scaling groups, security groups, and Amazon DynamoDB tables. To keep up the demand, the DevOps engineer wants to automate and creation of development environments. Because the infrastructure required to support the application is expected to grow, there must be a way to easily update and deploy infrastructure. CloudFormation will be used to create a template for the development environments. Which approach will meet these requirements and quickly provide consistent AWS environments for developers? Option A. Use FN import value intrinsic functions in the resource section of the template to retrieve virtual private cloud VPC and subnet values. Use CloudFormation stack sets for the development environments, using the cloud input parameter to indicate the number of environments needed. Use the update stack set command to update existing development environments. Option B. Use nested stacks to define common infrastructure components. To access the exported values, use template URL to reference the networking team's template. To retrieve virtual private cloud VPC and subnet values, use FN import value intrinsic functions in the parameters section of the root template. Use the create change set and execute change set commands to update existing development environments. Option C. Use nested stacks to define common infrastructure components. Use FN import value intrinsic functions with the resources of the nested stack to retrieve virtual private cloud VPC and subnet values. Use the create change set and execute change set commands to update existing development environments. Option D. Use FN import value intrinsic functions in the parameters section of the root template to retrieve virtual private cloud VPC and subnet values. Define the development resources in order to they need to be created in the CloudFormation nested stacks. Use the create change set and execute change set commands to update existing development environments. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a DevOps engineer has automated a web service deployment by using AWS code pipeline with the following steps. First, an AWS code build project compiles the deployment artifact and runs unit tests. Second, an AWS code deployment group deploys the web service to Amazon EC2 instances in the staging environment. Third, a code deployment group deploys the web service to EC2 instances in the production environment. The quality assurance QA team requests permissions to inspect the build artifact before the deployment to production environment occurs. The QA team wants to run an internal penetration testing tool to conduct manual tests. The tool will invoked by a REST API call. Which combination of actions should the DevOps engineers take to fulfill this request? Choose two options. Option A. Insert a manual approval action between the test actions and deployment actions of the pipeline. Option B. Modify the buildspec.yml file for the compilation stage to require manual approval before completion. Option C. Update the code deployment groups so that they require manual approval to proceed. Option D. Update the pipeline to directly call the REST API for the penetration testing tool. Option E. Update the pipeline to invoke an AWS Lambda function that calls the REST API for the penetration testing tool. Correct answer is option A and option E. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a DevOps engineer needs to apply a core set of security controls to an existing set of AWS accounts. The accounts are in an organization in AWS organizations. Individual teams will administer individual accounts by using the Administrator Access AWS Managed policy. For all accounts, AWS CloudTrail and AWS Config must be turned on in all available AWS regions. Individual account administrators must not be able to edit or delete any of the baseline resources. However, individual account administrators must be able to edit or delete their own trails and AWS config rules. Which solution will meet these requirements in the most operationally efficient way? Option A. Create an AWS CloudFormation template that defines the standard account resources. Deploy the template to all accounts from the organization's management account by using CloudFormation stack sets. Set the stack policy to deny update delete actions. Option B. Enable AWS Control Tower. Enroll the existing accounts in AWS Control Tower. Grant the individual account administrators access to CloudTrail and AWS Config. Option C. Designate an AWS Config Management account. Create a AWS Config recorders in all accounts by using AWS CloudFormation stack sets. Deploy AWS config rules to organization by using the AWS Config Management account. Create a CloudTrail organization trail in the organization's management account. Deny modification or deletion of the AWS config recorders by using an SCP. Option D. Create an AWS Cloud Formation templates that defines the standard account resources. Deploy the template to all accounts from the organization's management account by using Cloud Formation stack sets. Create an SCP that prevents updates or deletions to CloudTrail resources or AWS config resources unless the principal is an administrator of the organization's management account. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a DevOps engineer at a company is supporting an AWS environment in which all users use AWS IAM Identity Center AWS Single Sign-On. The company wants to immediately disable credentials of any new IAM user and wants the security team to receive a notification. Which combination of steps should the DevOps engineer take to meet these requirements? Choose three options. Option A. Create an Amazon Event Bridge rule that reacts to an IAM create user API call in AWS CloudTrail. Option B. Create an Amazon Event Bridge rule that reacts to an IAM get login profile API call in AWS CloudTrail. Option C. Create an AWS Lambda function that is a target of the Event Bridge rule. Configure the Lambda function to disable any access keys and delete the login profiles that are associated with the IAM user. Option D. Create an AWS Lambda function that is a target of the Event Bridge rule. Configure the Lambda function to delete the login profiles that are associated with the IAM user. Option E. Create an Amazon Simple Notification Service Amazon SNS topic that is a target of the Event Bridge rule. Subscribe the security team's group email address to the topic. Option F. Create an Amazon Simple Queue Service Amazon SQS queue that is a target of the Lambda function. Subscribe the security team's group email address to the queue. Correct answer is option A, C, and option E. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company wants to set up a continuous delivery pipeline. The company stores application code in a private GitHub repository. The company needs to deploy the application components to Amazon Elastic Container Service Amazon ECS, Amazon EC2 and AWS Lambda. The pipeline must support manual approval actions. Which solution will meet these requirements? Option A. Use AWS Code Pipeline with Amazon ECS, Amazon EC2, and Lambda as deploy providers. Option B. Use AWS Code Pipeline with AWS Code Deploy as the deploy provider. Option C. Use AWS Code Pipeline with AWS Elastic Beanstalk as the deploy provider. Option D. Use AWS Code Deploy with GitHub integration to deploy the application. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company has developed a serverless web application that is hosted on AWS. The application consists of Amazon S3, Amazon API Gateway, several AWS Lambda functions, and an Amazon RDS for MySQL database. The company is using AWS Code Commit to store the source code. The source code is a combination of AWS Serverless Application Model (AWS SAM) templates and Python code. A security audit and penetration test reveal that usernames and passwords for authentication to the database are hard-coded with code commit repositories. A DevOps engineer must implement a solution to automatically detect and prevent hard-coded secrets. What is the most secure solution that meets these requirements? Option A. Enable Amazon Code Guru Profiler. Decorate the handler function with @with_lambda_profiler function. Manually review the recommendation report. Write the secret to AWS Systems Manager parameter store as a secure string. Update the SAM templates and the Python code to pull the secret from parameter store. Option B. Associate the code commit repository with Amazon Code Guru Reviewer. Manually check the code review for any recommendations. Choose the option to protect the secret. Update the SAM templates and the Python code to pull the secret from AWS Secrets Manager. Option C. Enable Amazon Code Guru Profiler. Decorate the handler function with @with_lambda_profiler function. Manually review the recommendation report. Choose the option to protect the secret. Update the SAM templates and the Python code to pull the secret from AWS Secrets Manager. Option D. Associate the code commit repository with Amazon Code Guru Reviewer. Manually check the code review for any recommendations. Write the secret to AWS Systems Manager parameter store as a string. Update the SAM templates and the Python code to pull the secret from parameter store. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe.